Okay, so today we're going to talk about the Pythagorean theorem. So you guys have done this for the last few years, so this is just review. But the Pythagorean theorem is when we have right triangles, there is a certain theorem that always holds true. And that is, if we have a right triangle here, so if we have this right triangle, meaning it has a right angle or a 90-degree angle in it, if the longest side, which we'll call C, and then we have our two legs, which we'll just call A and B, if we were to add our two legs together and square them, so A squared plus B squared, it will always equal the longest side squared, so C squared, right? So that enables us to find pretty much any missing length, and this is pretty much one of the backbone pieces of math. So this is basically what is used anytime you're trying to find distance, and it's also kind of the backbone of an entire subject in math, which is trigonometry, which is what unit we're going to get into here. So we're just going to review the Pythagorean theorem here. So let's start by looking at an example. So this time, what you guys will see that you haven't seen in previous years is you're going to see stuff in radical form, because you guys know how to do simplify radicals and all that fun stuff now. So first off, to figure out the longest side, remember, it's always that side that is opposite the right angle. The right angle is always going to be the biggest angle in the triangle, because if that's 90 degrees, that means these other two angles have to add up to be 90 degrees. So there's no way that they can be bigger than 90 degrees. And the longest side is always opposite the longest angle. So longest angle is always opposite that right angle. So that means x here would represent C. So to set this up to solve for x, I would take my two legs and square them. So the square root of 10 squared plus the square root of 13 squared is going to have to equal x squared. Okay? Follow me so far? Now, when I square something that's being square rooted, remember, it just kind of cancels out the root. If you square something that's being square rooted, the root's gone and you're just left with what's underneath the root. So you'd have 10 plus 13 equals x squared. 10 plus 13 is 23 equals x squared. Now, am I done? No. Because I need to figure out what x is, not what x squared is. So to figure out what x squared is, this is where I square root both sides. Now, 23 does not have a nice even square root, right? If I do square root of 23, I'm going to get the square root of 23. So in the past, we've converted that to fractions. But since we are now dealing with radicals, radicals are a lot more accurate than decimals. Sorry, I said fractions. We're a lot more accurate than decimals. So we're just going to leave it in radical form. So x is going to equal the square root of 23. And that is my final answer. Okay, not too tough, right? Let's look at another example. So over here, the longest side this time is not going to be represented by x. It's 8. So that means x is one of the legs. So it's either A or B. So to set this one up to solve for x, I would do x squared plus 7 squared equals 8 squared. Okay, 7 squared is 49, so I have x squared plus 49 equals 8 squared is 64. Add minus the 49 to each side. That gives me x squared is equal to 64 minus 49 is 15. And then just like before, to get the x by itself, I have to square root both sides. So x is going to equal square root of 15. Now again, that's not going to be a nice squared number, right? But if I square root 15, I get the square root of 15 as my radical. And that's what I'm going to leave it as, the square root of 15. Okay. Let's do one more. Let's look at, let's do number 4 here. So this one, the longest side is going to be the radical square root of 226. So that means x and 7 are the a and b. So I'd have x squared plus 7 squared equals the square root of 226 squared. Okay, now when I square all those, I'd get x squared plus 49 equals, again, the root and the square cancel out, leaving 226. And then I'd minus the 49 to each side, which is going to give me 226 minus 49 is 177. Now, as you can probably guess, 177 does not have a nice square root. If I do the square root of 177, I get the square root of 177. So when I square root both sides, x is just going to equal the square root of 177. Okay, and that would be your final answer. Now, sometimes you might be able to simplify this radical, and that's fine. This always needs to be in its most simplified form. So your calculator does that automatically. But if your calculator did not do it automatically, you should know how to be able to pull out things that have roots, right? Move it in front. And that is what you're doing with the Pythagorean theorem.